Hey everyone, so in this video I will show you how easy it is to test an existing ROS package that you have using one of the public simulations provided by the Construct in ROS Development Studio. So I want to test a navigation package. I need a mobile robot. In this case I will choose the Kabuki one. Let's run the simulation. My package is hosted in a public repository here in Bitbucket. You can check this package accessing deconstruct/deconstruct_navigation. So let's clone the package in the workspace. So let's get into the CatchKing workspace, source, do a git clone. Okay, great. Now we have the package here. Basically, this package has an action server which is using this new message. It's a go-to-point 2D message. It's expecting as a goal a geometry message point, and it publishes as a result x and y coordinates, the distance to the point, and the status of the task, also for the feedback message. And of course the source code. Here we are subscribing the odometry message from the robot to get the current position, and we are publishing to the command vel topic to send the velocity commands to the robot. So let's compile the package. Here I have only the action server. So to send the commands I need to create an action client, but I will not create a new file here or even a new package, because I want to do it using the IPython notebook. It's easier, more fast to develop and debug the code using the notebook. So let's start creating here a new cell to execute commands. Let's start importing all the necessary modules like ROSPy, because we want to interact with ROS stuff. We need also to import the action lib module, because we want to send goals to an action server. The goals are 3D points, so from geometry messages we need to import the point type. And finally, from our package, which is go-to-point 2D message, we need to import the action server messages, and they are go-to-point 2D action and go-to-point 2D goal. Okay, great. Now we'll create a new cell to define a function that will send the goals to the server. I will call it go-to-point, and I want to send just x and y, because we are working with a 2D, so it makes no sense to send the z coordinate. Let's start creating a ROS node. I will call it go-to-point action client node, and I need to create a new variable to represent the client. So it's an action lib simple action client, and we are trying to access, let's take a look here in the launch file, the name of the action server, which is go-to-point server. So go-to-point server, and the type is go-to-point 2D action. Great. So the client must wait for the server before sending the goals. And now the goal that we must send to the server is point type. So let's create passing the arguments x and y and 0 for z. Now the goal object, which is a go to point to the goal type, passing point as an argument, and finally the client sent the goal to the server. Okay, so you're expecting a result from the action server, client wait for a result, and we don't want to wait forever, so let's define here a timeout using ROS by duration, and maybe 15 seconds is enough to the robot get to the point. So if we don't get a result, let's return a timeout message. Otherwise, let's return the result that we got from the server. And finally, let's call the function go to point, passing, I don't know, maybe 1 and 1 as coordinates. Okay, great. Let's take a look in the simulation where we send the commands. First, I need to reload my notebook because I have compiled a new package here, so my ROS environment has changed. Restart kernel, restart, okay, restarting, created, connected, ready. Okay, so let's execute the first cell. We can execute using the button here, or typing Ctrl Enter. Okay, so we have imported all the necessary modules. Now let's define the function. Great, done. And finally, let's send the robot to the point 1, 1. Of course, the robot is not moving because the server is not running, so let's launch here the go to point to the server. Go to point server.launch. Great. Now the server is running, and the robot must go to these coordinates. Okay, great, and true, because it got to the point. Let's change it to see server working. So if you think the robot's too slow or maybe too fast for your kind of application, you can change some parameters here in the launch file. And of course, we are working on a public repository, so feel free to contribute. You can take a look here in the code and change if you think you can improve the code. And well, I think this is it. I hope you enjoyed this video, and we'll be happy to hear your questions, your comments, so feel free to leave your comments in this video. Thank you.